The square root property. This is the first video in a series that we're going to be doing about solving quadratic equations. Now we've done some solving of quadratic equations already, and just as a reminder, a quadratic is just a polynomial where the highest power is squared. So it might look something like 4x squared plus 3x minus 6. It's a really common way for a quadratic to be written. But quadratics could look a little bit different. It also might look something like this. X plus 5 squared equals 9. And we can tell that this is a quadratic because inside the brackets we have an x of just a single power of 1. And because it's squared, that when we multiply x plus 5 times x plus 5 and FOIL it out, we're going to have a x squared term in that. So there are different ways that a quadratic equation might look, but the key is that the highest power of x is going to be a squared term. So previously, if we wanted to solve this equation, x squared equals 9, we used factoring earlier in this course. So we'd do something like this. We'd go x squared, take 9 away from each side, so we have x squared minus 9 equals 0. And then we would factor it as a difference of squares. So that would be x plus 3 times x minus 3 is equal to 0. And then we would recognize that we can use the zero product property to say that either x plus 3 equals 0, because if you have two things multiplied together equals 0, one or the other has to be equal to 0. So either x plus 3 equals 0 or x minus 3 equals 0. So that would mean x equals negative 3 or x equals positive 3. So that was our method beforehand. We've really only learned to factor quadratics so far in the course, so we'd have to solve these equations by factoring. But what if we wanted to solve x squared equals 7? Because even if you subtract 7 from each side, 7 is not a perfect square, so we can't factor it using difference of squares. We're going to need another method to solve an equation like this. So we're going to start just by looking at x squared equals 25. And we're going to use our understanding of perfect squares, which is to say that for x squared equals 25, that either x equals 5, because 5 squared equals 25, or x equals negative 5, because negative 5 squared equals 25. So there's two solutions to many quadratic equations, especially one of this form, x squared equals 25. Either there's a positive solution that 5 equals 20, or it's 5 squared equals 25, or there's a negative solution for x equals negative 5. The square root property in general says that if you have something like x squared equals k, so I'll say if x squared equals k, then x is either equal to the positive square root of k, or x is equal to the negative square root of k. So just like above, x is either the positive square root of 25, which is 5, or it's the negative square root of 25, which is negative 5. One way we can write this, and you'll see it written this way commonly, is that x is equal to positive or negative root k. So you're going to see that in a lot of future solutions in this unit. So we'll use the square root property now. We know that x squared equals 9, so either x equals the positive square root of 9, or x equals the negative square root of 9. So that would be x equals positive 3 or x equals negative 3. And if we want to go ahead and prove this to ourselves, we could just stick that positive or negative 3 back in the equation. And you'd see that negative 3 squared equals 9 or positive 3 squared equals 9. So that's our little check there. For the second example, we're just going to apply the same rule. If x squared equals k, then x is either the positive or negative square root of k. So in this one, I'll write x is equal to either positive square root 7 or negative square root 7. I'm going to write it as x equals negative square root 7. Now, there's no simplification that we can do in this case, but so I'm going to write this here, x equals positive or negative square root 7. So that's another way to write the solution. But there's no way to simplify the square root of 7. It's as simple as it gets, and it's an irrational number, but that's okay. It's a valid solution to the equation. And again, we could check to show that this principle is working, and we could take positive root 7, and what's positive root 7 squared? Well, you'd have positive root 7 times positive root 7 is just 7. As you know, the square is the opposite of the square root, so essentially they cancel out, and we did that when we were solving radical equations earlier in this course as well. And if we do this with the other solution, negative root 7 squared, well, because you have a negative times a negative, you end up getting a positive solution, and root 7 times root 7 is just 7. So using both solutions, both the positive and the negative, we can check them back in the original equation, and we see that we get positive 7 as the result. For an equation like x squared minus 50, well, all we're going to do is rearrange the equation so that it looks like the form we had earlier, which is that if x squared equals k, then x equals, and now if you want, I'm actually going to show you a way you can write this. We'll often do this, which is take the square root of each side, but when you take the square root of the other side, you show that you have the positive or negative square root. So x is equal to the positive or negative square root of 50. Except that 50 actually has a perfect square in it. We can simplify this. 50 is 25 times 2, and the square root of 25 is 5. So we can write this as a more simple radical as plus or minus 5 times the square root of 2. So again, there are two solutions. One solution is x equals positive 5 root 2, and another solution is negative 5 root 2. If we want to solve this equation, we're going to take a similar approach to the last question, which is just to first make it look like x squared equals k, or in this case, z squared equals k. So to do that, we'll divide each side by 3. And we get z squared equals 108 over 3. And if you can't do that in your head, which I can't, I'm going to divide it in my calculator. I get that 108 divided by 3 is 36. And now I take the square root of each side. And when I take the square root of the other side, I have to recognize that there's either going to be a positive or negative solution to this equation. So that means that z is equal to positive or negative square root of 36. Of course, on the left-hand side, that radical's canceling with the square, so I'm left with just z. And on the right-hand side, I have plus or minus the square root of 36, which I can simplify the square root of 36. That's a perfect square, so it's just 6. So z is equal to plus or minus 6.